Today I'm going to explain a problem from the Algebra and Number Theory round of the HMMT of 2021. Compute the sum of all positive integers n for which the expression n plus 7 divided by the square root of n minus 1 is an integer. So basically, we are given that this is an integer and n is a positive integer. The first thing we're going to do here is, so n plus 7 over n minus 1, take the square root of that. The first thing we want to do is reduce this. We see that we can make the top n minus 1, so n minus 1 plus 8. That's still n plus 7. So now we can just break this up into two equations. This is n minus 1 over the square root of n minus 1 plus 8 divided by the square root of n minus 1. So now, what we can really do is realize that n minus 1 is really the square root of n minus 1 squared. Oh, sorry, that parentheses doesn't look so good, but you square it and then divide it by the square root of n minus 1. And then you still add that 8 over n minus 1. So now we can actually just divide this. This is now the square root of n minus 1 plus 8 over the square root of n minus 1. So we have transformed the original equation, n plus 7 divided by the square root of n minus 1, into this. All we really care about is this here. It's a fraction. We need that to be an integer, and we are also given that n has to be positive, so therefore the divisor has to be positive. We can list out all the multiples of 8. Let's see. There's 1, 2, 4, and 8. Those are the positive numbers that multiply to 8. Now, the square root of n minus 1 has to be a multiple of 8 since we want integers. So therefore, the square root of n minus 1 is equal to, is 1, 2, 4, and 8 respectively. So therefore, we can just solve. Our first case is when n is 2 to get 1, n is 5, n 17, and our final n is 65 for this case. Now we have our four values of n. We add them up. 2 plus 5 plus 17 plus 65 will yield us our answer, which is 89. So we have found out the total sum of all the positive integers of n.